In 2016's higher level paper, question 1, we were given a question on the vinegar titration. So again, to begin this one, what we're going to do is identify what numbers in our information belong to which chemical. So to begin, to determine the concentration of ethanoic acid in a sample of vinegar, 250 ml of the vinegar was diluted to 250 ml. So that part is important there, and actually before I do anything else, I'm just going to write that my dilution, because I diluted the vinegar, my dilution factor is I went up to 250 ml from 25 ml. So my dilution factor is 10. So moving on from there, the diluted vinegar was titrated with a previously standardized solution, which contained 120 grams of sodium hydroxide in 500 ml. So that belongs to the sodium hydroxide there in the equation. Now back to our diluted vinegar. On average, 18.75 ml of the diluted vinegar were required to neutralise 25 ml of the sodium hydroxide. So my vinegar's green, I have 25 ml of sodium hydroxide, so that actually belongs to the sodium hydroxide, that does, so I'm putting it in blue. So now every number there has been assigned to a chemical. We can get on to actually calculating. So for which one now? For C part 1. We're asked to calculate the number of moles of sodium hydroxide in each 25 ml portion. So I want moles in 25 ml of sodium hydroxide. What I have is, so up above in the blue, I have 1.20 grams per 500 ml of sodium hydroxide. So I need to convert grams in 500 ml into moles in 25 ml. So in order to do that, I have to go from grams to moles. And to go from grams to moles, I have to divide by the molecular mass. So the molecular mass of sodium hydroxide. So sodium hydroxide, we have a 23 for the sodium, a 16 for the oxygen, and a 1 for the hydrogen, and that gives us 40 when we add those together. So to turn 1.20 grams into moles, I divide by 40, and we get 0.03 moles per 500 ml of sodium hydroxide. Still not what I want yet. I have moles in 500 ml. I want moles in 25 ml. So to turn this value into moles in 25 ml, I can divide by 500 and multiply by 25. And that will give 0.0015 moles per 25 ml sodium hydroxide. That's that answer finished. Moles per 25 ml. That's what it asked for there. Now for part 2, it wants the number of moles of ethanoic acid per mil of diluted vinegar. No, it's not finished yet. So I need to get moles per mil of dilute vinegar. So I'm going to start this one off the same way. What do I want? I want moles per 1 mil of my ethanoic acid dilute. What I have is 0.0015 moles of sodium hydroxide. So to go from one chemical, sodium hydroxide, to another, the vinegar, what we need to do is use our ratios from our balanced equation above. So I want to go from sodium hydroxide to my ethanoic acid. And if we go up to the balanced equation, we see that we have a 1:1 ratio. So we have 1:1. So if I had 0.0015 moles of sodium hydroxide, that means I had 0.0015 moles of ethanoic acid. But how many mils of acid did we use? How many mils of vinegar? So if we go back up to the top and we look at our green, we see that we used 18.75 mils of vinegar. So that 18.75 mils of vinegar contained 0.0015 moles of ethanoic acid. So we have 0.0015 moles per 18.75 mils of ethanoic acid dilute. Always put your labels in for your chemicals just so you can keep track of what you're actually working with. The question wants moles per mil. I have moles per 18.75 mils. So I'm going to divide by 18.75. And that gives me 0.00008 moles per mil of ethanoic acid dilute. So that's my answer there for part 2. So that's finished. Now in part D, we need to find the concentration of ethanoic acid in the original vinegar in moles per litre. So for D part 1, I want moles per litre of ethanoic acid original. What I have is moles per mil of ethanoic acid dilute. So how am I going to go from here to here? Well, first of all, I can turn my dilute vinegar into original vinegar, because I know from back up the top that my dilution factor was 10. That means that my original vinegar is 10 times more concentrated than my dilute vinegar. So all I need to do is to take my value for my concentration for the diluted vinegar and multiply it by 10 to make it 10 times more concentrated. So I have 0.0008 moles per mil of ethanoic acid, but now that's original. Nearly there. I want moles per 1,000 mils, moles per litre. Seeing as I have moles in 1 mil, I can just multiply it by 1,000. And that will give 0.8 moles per litre ethanoic acid for the original. That is D part 1 finished. Moles per litre of original vinegar. For D part 2, it wants the concentration of ethanoic acid in the original vinegar as a percentage weight per volume. So to work out a percentage weight per volume, we're just going to write down what that actually means. That means grams per 100 mils. So I need to take this value here, the moles per litre, and convert it into grams per 100 mils. So first of all, to turn moles into grams, I need to multiply by the molecular mass of ethanoic acid. And the molecular mass will be 12, and 3 ones for my hydrogens, another 12, a 16 for an oxygen, another 16 for an oxygen, and a 1 for the hydrogen. And that turns out to be 60. So I need to take my 0.8 and multiply it by 60. And that gives me 48 grams per litre. So I have 48 grams per litre of my ethanoic acid. And it's my original. But I don't want grams per litre. I want percentage weight per volume, which is grams per 100 mils. So to go from a litre to 100 mils, divide by 10. That will give us 4.8 grams per 100 mils, which is 4.8% weight per volume. And that is our final answer there to D part 2. It asked for the concentration of the original ethanoic acid as a percentage weight per volume.